All right, I think we'll now get started. Good evening, everyone. I welcome you to this webinar on External Movable Shading Systems. I am Yashima, a member of the core team of SDI, and I'll be moderating today's session. Today's webinar is jointly organized by SDI and the Building Energy Efficiency Project, also known as BEEP. The Indo-Swiss BEEP is a bilateral cooperation project between the Federal Department of Foreign Affairs of the Swiss Confederation and the Ministry of Power, Government of India. The overall goal of the project is to reduce energy consumption in new commercial, public, and residential buildings in India through energy efficient and thermally comfortable design. Today, our experts will talk about the advantages of EMSyS, also called as EMSyS, over static shading devices. They will also talk about how to estimate the potential of EMSyS in energy savings and thermal comfort. Also, we will look at examples of EMSyS technologies available in India and abroad, their costing, operations, and maintenance, and how some of these technologies have been implemented in buildings in India. I would like to acknowledge the support of the Department of Science and Technology and all the support of our supporters and affiliates. We have two experts joining us today. We have Pierre Jeboydorf, who leads the Swiss PMPU of the Indo-Swiss BEEP project, has over 35 years of experience, and has been involved in BEEP's conceptualization, overall planning, and management. He is also actively involved in simulation and performance monitoring, development of the Vayu Parvah tool, innovative technological solutions, and supporting the IEA trainings on buildings. We also have with us Prashant Bhanware, who specializes in building energy simulation, energy monitoring, and renewable energy systems, and has been instrumental in the development of the Eco-Niwas Samhita, performance monitoring activities, and project management and technical training. He is a certified BEE energy auditor and is instrumental in conducting the performance study of the external shading device system through field studies and simulations. Thank you for joining us, Pierre and Prashant. Over to you.
Thank you, Shima, for this introduction. Let me share the screen.
Yeah. Yeah, it's visible. You can go on full screen. Yeah.
Okay.
Thanks.
Visible?
Yes.
Okay. So as mentioned earlier, we are going to speak about external movable shading system. What does it mean? We will explain it now in the next couple of minutes or a little bit more to explain what is really this technology, which seems to be not well known in India yet, and I think which is even though it is something which is very fundamental for the high performance building, especially if you want to go net zero. So we are going to talk a little bit about the heat gain through windows, compare internal shading versus external shading, or static shading versus dynamic shading, and also have a little bit a quick overview of what is happening or what has happened in the world for external movable shading and also in India, and then the impact on the ground. That means what has been done in external movable shading as experiment in India, more specifically. Then you will get also a kind of guideline exposed on how to use external movable shading in design builder, essentially, which can be useful because often people have some trouble in, let's say, making a proper modeling with external movable shading. And that will be performed by Prashant. And then at the end, you will have a kind of a list of what we know about available product in India, knowing that there are not enough product at the moment in India, but that we have been working on it to know better. So we'll let you know where it stands now in India. So what we can see now as a general trend, that in let's say mid and high-end new residential building, etc., especially we can see that you can see my cursor. You can see that the glazing is often very a high portion of the facade. That can be something like 60–70% of the so-called window to wall ratio. And you see here, for instance, can you see my cursor, Shima?
Yes, yes.
Okay,
Yes,
good.
yeah.
And here, so what is interesting on this picture is that you can see here that some of the, you can imagine a living room which on the southwest facade with so much of glazing without any direct solar protection. It will be like an oven. And then here you see how in some region, and in Rajkot, we have seen that nearby one of the projects on which we have been working, that in some place, for some reason, we don't know exactly how it has happened, people are adopting ad hoc kind of shading, and all have done it in the same building. It's quite interesting because it is in few buildings nearby one place, and then after it disappears. But the people who do it, they do it consistently. And then you can see here that there is this always this impression that for the well-off, you should always have all glazed as much as possible, and that is certainly a tendency which already a tendency to go on. So we should first define a little bit the physics of it. So the indication of how much solar heat gain is going through a window is defined by the Bureau of Indian Standard in the NBC code, and we just show it here. So when you have the sun hitting the window, the glass, part of it is reflected. It depends on the quality of the glass. Depends if it's a reflective glass, or if it's a single clear glass, or if it's a double, it will change. And then part of it is also absorbed in the glass itself. If it's a multi-layer glass, then it will be absorbed at different layer, depending also on the typical kind of layer, which are low emissivity, or which can happen. This is not very common yet everywhere. And then you have part of it that goes through directly, that go directly through. And then you have really what is the transmission of the overall heat gain solar. And then you have a secondary heat gain. Imagine that this is a relatively dark glass. It will heat up with a lot of absorption. So it will then be heated to a level where it will re-radiate on one hand and have convection heat exchange with the internal zone. And this ratio between the total heat gain, the overall solar heat gain, and the secondary heat gain is the solar heat gain. And the solar heat gain coefficient is the ratio between 100% of, if there was no glass, but that it would be tight, and what you actually gain. So typically, it has replaced recently something which was called solar coefficient, which was in relation to the single glass actually, but now it is really in tune with another value which is used more in Europe, which is called G value, and it's approximately the same as the solar heat gain coefficient, SHGC, the acronym. And this value corresponds really to the heat gain that you get in relation to the solar radiation hitting the same glass. So typically, a single glass has a value of about 0.88 normally, a double glass in the range of 0.75. Then a low E coating glass can be in the range of maybe 50%. The lowest without a lot of color are now in the range of 29–27% for the glass. But that means you cannot cut really a lot the heat gains by having glass. And also nowadays, the glass are quite expensive also in India when they have this kind of quality. So now just to explain a little bit the phenomena is that generally when you see that the sun is hitting a glass, let's say here we have a blue color, what is happening is most of it goes through, especially if it's a single glass or a double clear glass, you can say between 88 and 78%, 75% go through. If you have a shading inside, which can be either a curtain or which could be a lamella blind inside, or what is happening is that this red arrow is showing what is the heat which is entering, the solar radiation which is entering through the glass, and it will hit this curtain or this blind. And what will happen is that most likely it will not reflect, it will reflect a little bit. You can see this arrow, which is a little reflection, which is directly, let's say, the reflection through the glass, and that's what is not entering. But what is inside then is going to, is going to be exchanged as a solar collector in a sense. It will heat up by radiation because it is heated up inside the room, and it will also heat the air by circulation. So, and typically you can say the solar heat gain coefficient, that means the ratio between the solar radiation hitting the glass and what is passing through for a single glass is typically in the range of 0.75 if you take into account the various components. And then if you have an external shading which is lowered, again, it can be lamella, it can be a fabric cloth, it can be it could be also a shutter on hinge or on rail that covers. The important thing is to have something that does not allow the sun to hit directly the glass. So what is happening? It hits this external protection, which is the external shading. And what is happening is most of it is rejected either by direct reflection or because it is detached somehow from the facade, and that means air will cool it as well. So it will not reach very high temperature if it's properly designed. And then what is happening is a little bit still go through by reflection or by transparency if you have a fabric cloth which has got some holes in it, and part of it is going to go inside. And typically for a single glass with a good external shading, the solar heat gain coefficient is around 18% for a single glass. If you have a double glass and even a lower E coating glass, then it can go down to 10% quite easily. So that means the potential is normally in the range of 4 times the reduction between this situation, that means the internal shading system or external shading, movable shading, you are able to reduce by a factor 4 approximately the net heat gain. So here, these are some of the comparison, which some of the comparison you have if you have a static shading, typically kind of balcony. The balcony reduces in the tune of 8 to 10% the heat gains across the window, typically in this case. But if you have instead of that a good external movable shading, you are reducing the discomfort hours in a naturally ventilated room, in this case, of about 30 to 32%. So that means you are reducing the number of discomfort hours on more than 30% just by having this protection outside. So here you see an example of what was tried, and Prashant will explain better in detail later. The typical kind of blinds which have a kind of what we call a drum on which it is rolled, and then you are unrolling it, whether it is manual or it is by motor, that depends. and it blocks typically the direct and the diffuse radiation. This one is a textile, so it leaves a little bit heat going through. So here you see, for instance, at 3 o'clock or 5 o'clock in the afternoon, that if you don't have a protection, if you look at the front path, you can see that the windows are not covered at all, even if you have a balcony. So that means you have, especially at 3 o'clock, the sun which is lowering a little bit, which is directly heating the windows, and there you reach sometimes something like maybe 700 watt per square meter. If you have a single glass, it will give you almost 600 square meters. So you get suddenly like a window like this, which may have approximately 2 square meters, something like 1200, 1500 watt, like if you have an electric heater of the same power inside. So the trial which I've conducted in Bourgaon by BIP have demonstrated this this kind of thing. Prashant will give more detail later. So now I just want to go a little bit in the let's say some of the scientific support or technical support to the idea of external shading. So there are a number of things which have been published historically. Switzerland, you can say, was a precursor. The first lab testing of external movable shading was in 1974, the first report which was published. So it's almost 50 years ago now. And here we have looked also, we know and we have checked again that LBNL, Lawrence Berkeley Laboratory, they have done a report on high performance facade solution. And they, in 2009, it was published, and you see here that they were saying exterior shading system were found to yield net zero energy level of performance in a sunny climate and significant reduction in summer peak demand. And here on this table, you can see for interior shade, the potential on the cooling loads of reduction compared to a single clear glass or a double clear glass, the ratio within the same range. You are in the range of 15 to 20%. When the moment you have an external shade, whether it is manual or automated, it changes a little bit the ratio. You can see that the cooling load is reduced. The cooling load through the window, of course, the cooling load through the window is reduced by about 85% in both the case. And the peak cooling load that in relation to the solar heat gain is reduced by a factor more than 4. You can see that the maximum cooling load is in the range of 8 to 9 watts per feet square. That means almost 100 watt per square meter of heat that you're gaining through the window compared to 1.6 to 3, let's say around 20 watt per square meter in the case of external shading. And these are things, so we have again taken a few excerpts of this, where the report, which is high performance building facade solution, so you can find it easily on the site. You have here the reference to this report. I think it's quite an interesting one. And they have shown that the peak demand saving benefits at aggressive net zero level of performance. So which means it is really something, as per the NLB, say that it is helping going to net zero building. And also their comment, which was not a surprise to me, but that even though in US it was not very popular, they say the system are robust, fairly mature, and practical. And so the automated roller shade, for instance, in Switzerland, we have a standard which asks, and for the label, we have a label which asks automatic control of the shading. It reduced the loads by about 80% compared to other, in comparison to what you are getting through the window. And then, so they were saying they have tested 4 different external blinds, typology, and they say the reduction in heat gains and cooling load due to the window was in the range of 80%, you can say. So later on in 2014, they came with the same project in phase 2. And then again, they state that they relate to this report of 2009, and they say exterior shades are reputed to be superior for solar control and can also be effective for daylighting, as was determined in the phase 1. And also here they have gone in different testing and different trial more on practical level in some buildings. And they say the system can be used to reduce peak cooling to level where low energy cooling, such as natural ventilation, radiant cooling can be used. If exterior shading and advanced window are combined with low energy cooling strategy, performance will achieve level that enable net zero energy goal to be met. So it's clearly a statement by LBNL that external shading are part of, let's say, the road to net zero. Now, I would like to show you a little bit how not sophisticated things, but mostly shutter are in the world. It's a quick diapo show, a slow, and you will just what is happening. We have done this just to show how in the world, first in Jaipur library, then in Calcutta historically, or in again you can see that they were, you can see in North Africa, South in Australia, in Singapore, in the historical district in some case, in Thailand as well, in Kuwait. In Italy, this is very common. In France, the same. In France, whether old or new, in Germany, lamina blinds are becoming more and more popular. In Switzerland, there are shutters, but we also have different kinds of shutters. We have fabric blinds, we have lamella blinds in the ground number. We can even do some Ducat retrofit. And in Andalusia, in Spain, where it's 42 in summer, you can see that all the windows are covered by something external. In Portugal, the same. In Germany, again, some other things. In Argentina, we see also. Mexico, also some kind more static. And in Greece, you can see that every window is covered by a shutter. In Cuba, also, you can see that everywhere people do have solar protection. So now if we look at the map, that we can see that the world over, you can say, not all country, it's not an exhaustive also, it shows some of them where you can say you have external solar protection, whether they are a simple kind of shutters on hinge, or it can be sometimes kind of chicks. It can be any kind of thing, or a fabric blind, or it can be a roller blind, it can be all kinds of things, but it's always something which is there to protect from the heat gains. And for instance, in Greece, if you go in Athens, you will not see a window, you will not see glass, you will see only solar protected windows. And so here, if you look at some of the examples that we know, of course, there is the famous library of Sept University, which has this vertical louvers, which have been installed and are quite successful. They are mostly manually controlled, and but they are quite sturdy. The only problem with such thing that it's relatively intrusive in architecture, and it is also, let's say, quite expensive at the moment because it's more like an artisan ship than rather an industry product. Here we have other example of this in Ahmedabad. There are a couple of buildings which are equipped, and I would say the client are generally happy with it, and the users as well, because people are really not suffering so much from the solar radiation direct heat. This is another example with more imported material from a company called Ransom. And you can see here that the blind starts from the top and is going down slowly with in this case, it's a motorized. But these are examples that we have seen, some of them what we have seen in India, which are on the market, but for the moment, it's still a niche market because it's very expensive at the moment. And yeah, before I I think that's what is very important in India is now they are at the end of the presentation. Prashant will show you some of the available system which we have found in India by doing some little bit market research visits. It's still marginal, but we think that it has to go on, especially that India now has committed to be net zero in some years. And I think without external shading and some glass, it's very difficult to think you can become net zero. So I give it to Prashant for the rest, unless there are some questions right now which are in relation to the general concept, the applicability, and if there are specific things we can answer also now or later at the end.
Yeah, Pia will take questions in the end. Yeah.
Yeah.
Okay, so so let me continue. So I'll cover the rest of the topics which are already mentioned in the beginning. So I'll start with the EMSyS performance monitoring. So just showing that how things perform on ground, and for that we did a monitoring study. This was done in Gurgaon. So we rented 2 flats, exactly one above the each. And we put EMSyS in 1 flat and 1 without EMSyS, and then we measured the performance in naturally ventilated condition as well as in air conditioned mode. So these are the pictures of the instrumentation, what was done. So I'm not going to the details. Let me show you what was the result or outcome of the study. And this graph I'm showing, this was done in naturally ventilated mode, which means the air conditioning was off. The windows were open during the night time for ventilation purpose, and during the daytime, the windows were closed. And in case of EMSyS, the EMSyS was down during the daytime. And the other case, it had internal curtain which were on during the daytime. And what you see, the 2 graphs, red and blue. So the red one shows without EMSyS, or you can say with internal curtain, what is the normal practice. And the blue one shows the operative temperature with EMSyS. So you find, and this was done in the March, and you also see the corresponding solar radiation which was there during that day. So if you see, if it's little clear day, so if the radiation are going 600, 800, you can easily achieve a difference of 3 degrees, 3.5 degrees in the inside temperature. And the similar trends we found in the June also. So this was the study is documented and also kind of put on the website, so that is a measured case study is available with the public. And what we found that there are very few case studies or actual performance case studies which is available in the public domain. So it was an effort to put that resource available in the public. So then in air conditioning mode, we also did the monitoring, and here we were measuring how much cooling is being delivered by the air conditioning unit. So we did not measure, we also measured the electricity, but what I'm showing is the kilowatt hour thermal. So which means how much cooling is being delivered by the indoor unit of air conditioner. Again, the red one shows without EMSyS, or you can say with internal curtain, and the blue shows with EMSyS. And what we have found, if you see the difference, there was a difference of about 32% in cooling electricity demand, or you can say cumulative cooling delivered. So which means you will be able to save around 32% of electricity in cooling with the use of EMSyS as compared to using an internal curtain. We also measured the lux level, like with EMSyS somebody will say that, okay, if I put something outside, will it become too dark? But that's not the case. Depending on the product, you can have the results other ways. So what you see here is the lux level, the test room with internal curtain, and the test room with EMSyS. And you see the lux level at different point of the day. So because this was west facing, during the daytime, the lux levels were quite low, and even during the evening time when the sun is hitting, because of the internal curtain, the inside lux levels were not that great. But with EMSyS, we could get quite good lux level inside the space. So roughly about 12 to 14 times lux levels were there with EMSyS as compared to internal curtain. So it is helping in both ways. It can give you enough daylight, as well as it can, of course, it can save in reducing the heat gains. So that was on the performance. And then if we want to calculate how EMSyS will perform. So if I want to evaluate what is the potential, and if I want to calculate through simulation software, then how do I do that? And here I'm showing with design builder, but there are other options also which can be used to calculate. So let me quickly go over those key steps. And I am assuming that people already know design builder. And then I'm trying to show that how you can model EMSyS in that. So if you want to model EMSyS, you need to know about these key variables, and you need to define in your model. So shading material, position of shading, what type of control, and what will be the schedule of operating the shading. So let me go to the, so I'm showing the screenshots where you have to give the inputs. So in the opening tab, under the window shading, you can define the external shading system. So you already have an inbuilt library, what you see here. So you can use one of them, whatever is suitable for your project. Otherwise, you can create one. Say, for example, here what you see is we have created one example, Saltis 92, which we also use for the monitoring purpose. And then when you add that, you need to define its key parameters, like its thickness, conductivity, transmittance, reflectance, all these parameters. So most of these things you will be able to find in the manufacturer's catalog or the product sheet. So for example, Saltis 92, here you see the some of the properties. TS is transmitted, solar, reflected, and absorbed. So 19, 68, and 13. So this is what we had to put in the model. And while you are putting the details, ensure that, say, for example, in this case, transmitted, reflected, plus absorbed should equal to 100, should be equal to 100. Because out of 100, how much is being transmitted, how much is reflected, how much is absorbed should add to 100. If you don't put, if they don't add up to 100, you will find some error in the model. So just make sure that you define it properly. And other details you will be able to find in the product catalogs. For example, openness factor. So you can say that, okay, how much is the airflow permeability is there. So that can be defined as 4%. You also get the data on the thickness. So it's almost half mm thick. So all those things you can get from the manufacturer catalog and then put them in the design builder. Then you need to define the position. So you have options like whether it is inside, mid-plane, outside, or switchable. So anyway, for EMSyS, you have to define it outside. So, and then if it's inside, you can do that, but it will not help you. And then it could be mid-plane also. That's the options are there. But for external, we focus on we keep it outside. And then we need to define its control. So whether how it is controlled. So one option is it is always on, which means shading is always there. One can define based on the daylight to optimize for daylight. One can define its schedule. Say, for example, I will say ki when the sun is there, 8:39, then I will put down my external shading system. And during the evening, 5:36, when the sun is not there much, then I can open it. So I can define the schedule. Else, I can also define based on the solar control, which means if solar incident falling on the window is above a certain value, then the windows will be then the shading will be on. And you can define it, the values, and the approximate value which is used here in Design Builder is 120. You can change it, but that is also a good enough number to control the heat gains which is coming through the windows. And there are some other options also. You can go more into details, but I would say having a schedule or solar based control is the most common control type which you should define. Then we can also define the operation schedule. On means it will remain on, and sometimes if you want to operate it only during the occupied time, then you can put okay, I will operate it whenever the occupants are there. So that all those possibilities are there, how the EMSyS is being controlled. So that was the kind of defining this in dB and how to calculate for doing the calculation to come up with the energy saving number or thermal comfort number. If you want to do a quick comparison of different shading products or different alternative or different combination of glazing plus shading, then you can also use Windows LVNL software, which also has a quite an extensive library of glazing as well as of shading material. So you can make your combination. Say, for example, here what you see is clear glass and there is air gap, and then you have the Saltis product. And you also have a lot of products already available in the library, so you can check. And here what you can do is you can quickly come up with the equivalent SHGC number, effective SHGC number. Say, for example, here you get about 0.19, and you can choose other products and find which product gives you the best result, which is more practical. So yeah, so this is a quick estimation of effective SHGC using different shading and glazing combination. So this is what can be done with Windows LVNL. Now, when you do the simulation, I think understanding the results is quite important. And particularly, I would like to point on 1 or 2 points in Design Builder, how the result is shown and how you should post-process it. So when you are doing a simulation, you should look at 2 results, what you get in the Design Builder: solar gain exterior window and glazing. So these 2 will give you how much total heat is coming through the windows. These are definitions. I'm not going to that, but let me give you quick comparison of results. So here what you see is the heat gain in case of clear glass. So what you will find at particular instance, that the total amount of heat gain which is coming through the window is 1.2, and what comes under glazing is 0.1, and solar exterior is 1.1. So you have a total 1.2 kilowatt of heat which is coming inside. So do remember like the share of solar gain exterior and glazing. Okay, let me go to the next slide. And in case of internal curtain, so if you have internal curtain, then a lot of heat, which is already kind of explained by here, it is absorbed by internal curtain, which is kind of which has already come inside the inside your space, and then ultimately goes to the goes as heat to the zone. But here, I think if you are going to use design builder, then be careful that here you should check the summation of these two things, glazing and solar gain exterior window. What you see here, solar gain exterior window is like whatever has come and passed through the internal curtain. So that's what the number shows here as solar gain exterior window. So it will look very small, and you may get confused that, okay, with internal shading, I am reducing a lot. But look at the number glazing. So whatever has come and absorbed by the curtain, that is accounted here under glazing. So so your total heat gain for this particular instance is 0.86 kilowatt. If you go to in case of EMSyS, because the heat is already reflected outside only, very less amount of heat comes inside, and then you see reduction in both solar gain exterior window and glazing as well. And the total heat which is coming for at this instant is about 0.22 kilowatt. So the suggestion to the participant is that when you are doing EMSyS modeling, then look at both the numbers, glazing and solar gain exterior window, and then do an addition. So if, for example, here, what you'll see, 1.2 with internal curtain, you will gain something, but not much. And then you will see the numbers in under different head. So 0.81 under glazing and 0.05 under solar gain exterior window. With EMSyS, you get quite a drastic reduction, almost 0.4. So just the advice, like instead of checking solar gain exterior window, consider total gain from the windows. These are the list of tools which also can be used for external movable shading system monitoring. I will not go into the details. The presentation will be shared with you, and some of the key attributes are shown here. Coming to the EMSyS product, which are available in India and worldwide. So we have quite a wide range of EMSyS product available, although I would say the EMSyS market is very small at the moment, but it is likely to expand quickly, and particularly because of the, you can say, the net zero targets and all those given, and EMSyS will be a part of that movement, important component in that. So what you have in India right now is like a bamboo chick, you all would know, and green net. So these are the simple and cheapest form of external shading. The product life may not be that long, but the cost is quite low and reasonable. One can you will find like this kind of ad hoc shading in lot of places. Then you have external screen. This is becoming quite popular in putting vertical screen on the balconies. And this type of products ranges from like 350 to 800. So slightly higher than your normal product, but these are more stable and sturdy products. Then you have vertical louver, what we saw in the some of the case example. And this is quite, I would say, the limited product kind of thing. So the costs are quite high. So if you see 50 to 60 versus 2200, so there is a big difference in that. Then you have other type of products like awnings. You have PVC blind, and then I would say lamina blinds, these are the most, you can say, sophisticated, or you can say best external movable shading products available, and it can be controlled, automated, and normally these products are not manufactured in India. These are mostly imported. But the price is, and the prices are also on the higher side. So it's about 2,000 square feet, 2,000 rupees, 2,000 per square feet. So these are the broad project range in India. And there are few others also, like shutters are also quite popular, and they do exactly what other EMSyS products do. You have metal blinds, and you can have all sorts of automation and controls, and you can program the EMSyS based on a different type of logic, or the, and you can define the schedule based on the time, year of the day. So all those possibilities are there with the EMSyS in kind of sophisticated control to reduce the heat gains and optimize for the daylight. So considering all this background and like all the work which we have done, so we are also developing the policy paper for Bureau of Energy Efficiency in line with the going towards net zero. So what we have done is we did multiple sets of simulation, and then we have come up with the saving potential through EMSyS, and we have taken the average scenario. So what we have found that about 20% electricity saving is possible by using EMSyS, and if the EMSyS penetration goes slowly, then we can achieve significant saving in the future. And we also kind of identified which states have more potential, or where we can start focusing on EMSyS first. So that has also been highlighted here. Say, for example, the 3 states, Uttar Pradesh, Maharashtra, and West Bengal. These are the states where you have, it is also related with where the more construction is happening, where more urban population is there. So it's also linked with that. But if we want to push this, that is the these are the states where we can focus more at the beginning. And all these numbers are kind of documented, and we are submitting it to B, so that at the policy level something also comes to push EMSyS in the buildings. There are some of the numbers which are mentioned here based on the calculation. So we can save, you can say, up to 10 thermal power plant of 100 megawatt capacity are able to put EMSyS in at this rate. And we can also save 24 tons of CO2 emission in 2020 alone, if we are able to put this much of EMSyS. So yeah, so this is the last slide. So all the EMSyS related resources what we have are there on the, there is a web page dedicated for EMSyS, which you the link is given there. You will find all the details of the performance study, and you will also find a detailed manual on EMSyS product, where you can find all those technical details related to cost, manufacturers, the effective SHGC, and its operation and maintenance. So this EMSyS manual will be quite useful in that. And then there are some other things also which are available. So with that, I'll stop here, and we are open for any questions.
Yeah. Thanks, Pierre. Thanks, Prashant. I think this session would be very useful for our students, given that they have just submitted deliverable 2 and are working on actual, design and implementation of all the strategies, which would include shading devices as well. I'll now take the questions. But before that, so on the slide where you showed the costing of different EMSyS, so bamboo chick is in meters square, while rest are in square feet. I just wanted to confirm if that's right.
Yeah, that's correct.
That's correct. All right. Okay. All right. Yeah. Thanks.
It's quite cheap, green net and bamboo chick.
Yeah. Okay. Yeah. Okay. The first question. The question is: we have been taught to use shading masks to design shading devices. Can you tell us how to use shading mask for movable shading devices?
Actually, it's relatively simple, because what you do is that whenever the solar radiation hits above, let's say 100 watt per square meter per window, then you are lowering the blind. This is the logic in control, and it's also what people do normally. That means they will in the morning, when you are no more have a natural ventilation with window open, you close the window and you lower the blind. At the same time, there is no mass logic there. It's really when the sun is hitting, that's when you are lowering them. It doesn't make any sense anymore, let's say.
Right.
It doesn't mean that you, of course, it makes sense for daylighting. That's different. In terms of the heat loads, depending only on the fact that you lower or not the blind. If you lower the blind, you are reducing the heat gain through solar by about a factor 4 at least.
Okay. Thanks. Next question. Should color of the shading device be a consideration?
Yes, it does, because if you have, let's say, very dark shading, they will heat up more, and then they will transfer some heat by radiation to the glass behind. So ideally, you use rather clear components. There is sometimes slight difference with when you have lamella blinds, because lamella blind in some case, if they reflect very good, then at the same time they increase also the reflection of the solar radiation at the same time. So there is sometimes an optimum, or the design of the blade must be in such a thing that you don't have direct reflection going into the zone. But generally speaking, clear, if it's a fabric, it's better if it's clear. If it's shutters that you are using, it's also better and clear, because they will not heat up so much, and then they will have the solar heat gain coefficient will be maximum when you have clear colors.
I think higher the reflectivity, better it is. So that's the, you can say, the choice of the.
Right. All right, thanks. Next question. What if we want to implement more than 2 control types? I think, an interpretation of this would be, different shading devices on different directions. North side can be different, south side can be different, that kind of a thing.
That is quite possible. Say, for example, I think everyone would have seen the sun path and everything. So, say, for example, on southern facade, static, like the overhang or some static shading will help a lot. But for, say, east and west, you will not be able to control the solar gain by simple static shading. So for east and west, you can have different shading solution, and you can also define different control operation. Say, for example, on the eastern facade, you can operate them more like on during the first half of the day. And on the western facade, you can you can put more control on the second half. In the first half, it can remain open. So all those possibilities are there. So you can define how you would like to control, and with the kind of power of simulation tool, you can quickly gauge like what will happen if I do this or if I do that. So,
but I think there are two ways of understanding the question, because one of the question is whether you have two parameters. One could be, for instance, the daylighting level, or the other could be the temperature outside, the other could be the solar radiation. So in some case, in let's say building which are very highly sophisticated with their building management system, you can have 2 or 3 criteria to lower them or to take them up, depending on all these criteria with a different algorithm. So it is possible, but it generally then with a higher level building management system.
Right. Yeah. All right. Next question. Is the LBNL software free?
Which software? Windows?
yes, so Windows is
Yeah.
Windows
Yeah.
is free. You can download it and use it, and it also has a good you can say database of you can say shading and glazing product.
You can say reference software in the world nowadays for what is touching everything which is transparent on the facade of a building, because you can have sandwich, you can also have some part. It's like just lacking some of the dynamic of airflow into it, but they are adding regularly new features. So I would say in the last recent year, now you can almost look at any kind of composition, if it's multi-layer, if it's a multi-glass, you can really, it has even in a sense replaced a lot of the testing nowadays, because it's so accurate, I would say, that in many cases, if you do the testing, you will get the same result as the LBNL software normally. So it is almost a reverse now, that you need less testing, because if you don't do something very exotic, you get the result directly with such a software. And it's free, of course. And the interesting is it is connected to, for instance, the database of you can, as Prashant was saying, you can connect it directly to Design Builder Energy Plus. You can also use it in Transys. So you really easily introduce your own kind of glazing or complex, including some shading, into directly the softwares. It's a little bit work. It's a little bit expert work, but it's not so difficult. And as so difficult, and as Prashant showed, you can just follow a strict rule, and then you will get proper results.
Right. Yeah. Thanks. Next question. How does one incorporate external shading with sliding window?
I think sliding window is maybe the simplest application, because there is no conflict between external shading and sliding windows. It's wrong. The issue in India is that there are still a lot, and for various reasons, people have casement window toward outside. Then it's a little more difficult, because that means you could either have the window open and lower the blinds, but you cannot then close the window anymore, or you would have closed, and then you should have an access without opening. So I would say the practicability is more an issue with external, with casement window toward outside. But if it goes inside, if you have casement window to the inside or sliding, it is just not a problem. You just have your external shading, which is hanged on the facade, and normally that's the most common feature, which is not so common also in India always, is that normally the windows are in a recess in the facade, and normally able to have, let's say, the drum where you have the rolling blind, it should be included inside the facade normally. But I know it's not yet a common practice, because it's not yet a common, let's say, item included in the facade to start with.
And also, also a possibility that you can have a controls inside the inside the room. Say, for example, if you want to lower up, put the blinds up or down, you can control it from inside also. So that all that is possible.
You can have a handle with the kind of small gearbox, and then you can do it from inside. And it can be motorized also, but I would say it's cheaper to have in India. It's cheaper to have it with the handle, and you can very well lower or having the blind lowered or you lift them from inside directly with the handle. In some of the case, I think the issue for the conflict is again with casement window to the outside. If you want to have, let's say, curtains, shutters, external shutters, it is difficult to close them if you have the window which is closed inside. And so that's where I think in architecture there are a number of case develop guidance on how to make this. I think it's important, but that will come mostly when I would say really the practice of thinking about external shading will come for the architect as well. And I must say for the time being, it's not yet there. It should come. That's why it is important to talk about this to the young people in India, because they will be the one who will introduce later all these technologies.
Yeah, certainly. Yeah. All right, next question. So vertical blinds and especially fins break up the continuity of the view from the interior. And we have heard experts say that one should not use them. What is your take on that?
I would return the agreement to the because if you have internal curtain, have you seen how many buildings have curtain drawn inside all the day? So there is no view outside also. So that means I think it's quite a false understanding of what is happening, because if you see most of building nowadays which have a lot of glass, people tend to close the blind for the whole day, and so they have no view at all. If you have external shading, which are either lamella or a little bit transparent material, you still have the view outside. So I think it's a wrong statement.
Yeah.
I'm not saying that that having very dark blinds is not an issue, but normally, as Prashant was saying, we can show that the daylighting is better with outside shading than with inside kind of curtain or thing like this. So generally, the curtain are mostly opaque, and they completely cut the daylighting, for instance, without cutting the heat gain.
I think you also have different, you can say, product or solution, which can give you a good balance between the light and heat. So you can choose, like, if you want to cut down a lot and you want to keep it simple, then you can choose something which is like more opaque. But if you are able to control better, like lamella blinds, then you have, you can say, full flexibility in restricting the heat gain as well as getting the daylight and views.
Right. Okay. Next question. What is your take on using dynamic glass over all these other shading products?
What is the question about dynamic glass? Is it switchable glazing?
I think dynamic glass is it's clear glass and changes to electrochromatic. Yeah.
Switchable glazing. So I would say that we don't know what will happen in the future, but at the moment, first, they cost much more than external shading can be in the market if once the market is developed. Secondly, they also need power. It's not really a passive system. Contrarily to, for resilience, let's say it's a difference, because if you think of if you have a power cut, if you have a disruption, when you have your shading outside, you are still surviving inside the house. If you have, let's say, this kind of electrical system, which are, so you have the chiller, your AC will stop, and your dynamic glass will also become, again, transparent, most likely. And then the thing is, it's also in terms of comfort, it seems the temperature generally of the surface are also higher than when you have external shading, because they are cutting the solar gain through, but they are also heating up with the absorption they have. So I don't have a black and white answer on this, but I think that this to me seems a very sophisticated answer and very expensive for something which is so simple to do with an external shading.
Yeah, yeah. A dynamic glass at this point definitely is very expensive. So, yeah. Next question. Do you have any cost savings study for this?
We don't have, let's say, a generic cost study for the simple reason that the market is not yet ready. So that means the products are still overpriced, generally, we can say. But if you make a projection with costs that they should be, the payback on the electricity you are saving is quite fast, actually. And if you compare with investing in a higher COP AC in comparison, you will gain more in investing in the shading and save directly the energy and for long without any additional cost after. But agreed, let's say it is also, I would say, the tendency, let's say, in the country where people use it since long, is that nobody asks this. The question is, it is directly integrated in the building cost. It's not even a question. I mean, if you say there is an AC, there is also obviously shading. It's even mandatory in a country like Switzerland. You cannot escape to have external shading because you don't get the permit to enter the building in many cases. So that means it's part of a cultural and legal approach, in a sense, that makes that there is no more a question about this, because it has been demonstrated since long that the buildings are much more efficient with that, and it's the cost is no more an issue the moment in market.
Right. And I think this can be something that the students can do. I mean, if they're so interested in cost savings, and cost estimation is part of, their challenge. So yeah, that would be interesting to see.
As Prashant has shown, if they have done the right setup with design builder, because if I understand, SDI engaged students have access to design builder, then they can easily do a cost estimation, or let's say an energy comparison, and then do the calculation per square meter, how much they could invest to have a payback in 2 years, 5 years, etc., and see and compare it also with the 5-star kind of new AC, and you can see that, of course, it's not saying you should not go for a high-star AC, but if you combine both, then you can reduce the cooling total, the electricity, by more than 60%. If you add external shading plus a high performance AC, then you are reducing, and you can really, it is the way towards net zero is clearly with external shading.
I think you can also refer to the EMSyS manual, where you can find a different type of product, their performance numbers and their cost. And with simulation, you can come up with the energy numbers and you have the cost number. So there you can get a good estimate how much, say for example, your payback period and all those things. And even when you account for payback and all, you should also consider the reduction in system size and all associated savings as well. Say for example, with EMSyS, if you require, instead of 1.5 ton AC, if you require 1 ton AC, that also you should account when you do the cost analysis. And also you can say the power backup requirement for that, and all those things you should think about when you're doing the cost calculation. We do not have the ready-made number, but that can be done, and you should try to do that.
Yeah, thanks. I think that's great advice for the students. Okay, next question. How do you decide the balance between daylighting and heat both of them conflict at certain times. EMSyS data on daylight shows only point in time illuminance. Have you tested the spaces for benchmarks such as UDI, SDA, or ASE?
So I think during monitoring, we did it a point of time measurement, but through simulation, you can get all these numbers. So if you, I don't have the numbers in offhand, but overall you get quite a good, you can say lux level, or you can say all your indices with EMSyS, you will be able to know it.
And again, you have to relate this to a system. If you have a building which has a very nice daylighting without any shading and nobody has internal, but if you see so many of these buildings which are glazed, which you can see there are some white paper inside the building because people are trying to protect themselves. They have no view either, and they don't have also a good daylighting. So I mean, you have to think of the problem and see how actually the external shading are helping in solving this problem in a sense, because you can tune them, you can lower them only partly in some case, or whenever you have really no direct radiation, you can leave them open all the time. And if you lower them, especially in India, where when you have a lot of clear days, you have 100,000 lux outside. So if you think that you need only 300 lux inside, that means it's only 0.3% daylight factor. So there is also this relation that the difference, let's say, with the northern country, where in winter we have, let's say, 10,000 lux outside, then of course they're the issue, but generally also we don't need the shading at this time. But in India, you have the chance, in a sense, most of the time to have very strong illuminance outside, which make that even if you have a ratio of 1% of daylight factor, you are still well off at the end, unless you have very deep space.
Yeah, right. Thanks, dear. Next question, and we've been getting a couple of questions regarding automation, so I'll probably just take it in one go. So one of the question is, how can automation be done with shading devices, or what are the available options in India? Yeah, those are the two automations.
At the moment, if you see the second example we have shown with this window coverage along the window, these are motorized, and they are, I would say, the tendency in the European market generally is that they are mostly motorized now. But it's for simple reason that eventually now the single handle is almost more costly than an electric motor. So, but actually, I think that automation is not an issue at all. It's simply at the moment the cost is quite high for automation of the blinds. That's why I think to start with you better have handle manual, but automated the devices. You can say. It is thought and planned by all manufacturers, you can say, of let's say, professional level kind of shading, not cheeks maybe, but all the other can be motorized.
Yeah, so I think you can have for automation, what you need a motor which can actuate the blind, and you need you can say a PLC kind of thing. And for that, you can define the logic, whether you want to control it based on your solar radiation, or based on outside temperature, or based on some schedule. So you define those logic in your PLC, and then the motor operates accordingly, and your shading device is controlled as per your requirement.
Yeah, but I mean, doing this would rather turn out to be, I mean, definitely expensive than a
cost is the major factor.
Yeah.
The solutions are there, but they are quite costly.
Yeah.
At the moment it's costly, but let's say the trend, I would say, if you see the trend in Europe, is that still many are manually operated in private house, for instance, or they have a motor, but it's ordered just by push button. And it's only, let's say, in hospitals, in the common, let's say, in office building, where there it is mostly automated, because also to solve the problem of who wants it up or down, it is always also an issue when you have open space, for instance. So generally, what happens is we give now, I would say, on most of office building, the user, if he wants to rise the shading and have it off, in a sense, he can do it, but then the building management system will again lower it after maybe 15 minutes or 30 minutes, so that there is no overheating because the blinds are raised.
Mm-hmm. All right. Also, Prashant, on your last slide, there were a few links mentioned. Could you
Yes.
probably put them in the chat box so that our attendees can, have access to them?
Anyway, we are going to share this presentation, so all the links will come. Maybe you want to put it right now, I can also do that.
Yeah, so I'll just stop sharing the screen. You're sharing your screen right now?
Okay.
Okay, all right. So maybe you can just put them in the chat, because we will be sharing the recording and, it won't be really clickable for them. So maybe they can just bookmark them, whatever is relevant, like that. Yeah. Meanwhile, I'll also move to the next question. So for vertical louver EMSyS, is the panel gap between the louvers fixed, or does it vary based on location, direction, etc.?
You think of the face, these vertical louver which are operated. They are, as far as I know, they are not. They are by group, operated by the people in each group. Maybe of, I don't know, about 10 or 20 of these are in the same lever. People move them accordingly. Generally to avoid the direct radiation going through. As far as I know, they are not motorized. The one I know, at least, so I cannot say for sure, but most likely they are operated manually. I would say it's not really an industrial product. It's really a crafted product, very nice, but it's not sought as an industrial product which will be motorized, I guess.
I think the question was about the design of the louvers. I mean, even if they are manually controlled, but the gap between each panel, the vertical panel, is it fixed?
Normally, yeah, okay. Normally, what happened is, I think at the beginning they had a kind of void in between, so that you could never cut completely the direct radiation. I mean, you could in some case, but now it seems they have started having it more like overlapping, so that if you close it, then you have no solar going through, but then it's also night behind. So I have seen that there is now, it seems, some version which have a little bit of hole, let's say a little bit of holes, maybe a few percent of opening through, so that you still get some light through, but cut more of the solar radiation.
All right, thanks, Pierre. Another question. Nowadays, MEVAN technology is picking up along with other temporary wall construction. Can the shading study be implemented on these to shade walls?
That's, I think you can imagine, if you want to cover with shade all the walls, it would be very expensive. It's better not to use MEVAN. I think that's better use insulating walls. Because MEVAN, I would say, is really something which creates problems, especially in the hot climate, where we can see that the temperature of the surface temperature in the room is reaching something. Recent measurements have shown that you get about 3 to 5 degree higher temperature on the wall in summer, and which means the operative temperature in the range of 3-4, about 3 degrees higher when there is MEVAN than if you have typically AC block. So I would say I would rather look at not using my van than solving it by putting something outside, because it's not realistic to cover a building with external shading, I think.
Yeah. Okay, next question. How about the material life for these shading systems? There was no discussion on this since the cost has been mentioned. Yeah.
It's a good question. Actually, I would say, because in a sense, I would say the experience nowadays, let's say in Europe, is over 50 years of experience with lamella blinds and things like this, that generally they last for 10, 20, 30 years, maybe with some maintenance. But I would say I was, for instance, in a building which had this kind of lamella blinds, and out of maybe 600 of them, there was never one which was changed over 10 years. So which means if it's a good quality system, there is no issue with the maintenance. But of course, it has to be a good quality. The danger is that if you start, let's say, with a market where people are of the quality that comes, then it will, of course, kill the market to start with. So what is important is to have, let's say, a high technical quality of systems, and they will last for, for instance, if you take an example, the University Hospital in Lausanne, which is 20, has lamella blinds which are there for something in the last 40 years.
Mm-hmm.
So I would say, I'm not saying there is no issue at all, but the thing is to start with a decent technology and proper design, because I think there is a lot of expertise with the people who have been making them since so many years. And one of the issues, of course, to try technology transfer so that instead of starting from nothing, you get support from a company which may agree to support other companies in India to start doing this, so that you avoid, let's say, the long learning curve by trial and error.
So I think a lot of information like related to life and all, you will be able to the EMSyS manual, the link which was shared in the chat. And if somebody would have already opened it, then they can find it. You will find some of the key parameter for a different type of EMSyS product, which you can find in the manual. So for example, cost, how's the tolerance to the wind, what is the typical life in years. So all those things are like broadly given. So you may need to get more specific information for a particular product which you are considering, but a variety of product like under different categories. This information is already there in the manual, and also you have been given its operation and maintenance, like what are the key things which is involved in its operation and maintenance. So I suggest that if you are thinking about EMSyS, have a look at the manual. It will be quite a good starting point with a set of information related to cost, life, everything.
Yeah, certainly. Yeah. Next question. Can this analysis of EMSyS be done with BIM so that it becomes easier for the engineers to plan accordingly?
I think, I mean, today, let's say all the reputed manufacturers in Europe, they can give you directly the BIM component. I mean, you can integrate them into the drawing. But yeah, I think analysis, I don't know what is needed in the BIM, because it's more like if you want them, you have to coordinate. Of course, one of the issues will be that the architecture has to cope with the presence of this system. So typically what is happening, let's say in the European architecture in general, for instance, the window is in a recess. It's not in the same plan as the facade. It is in recess, and most of the time the drum where you have, for instance, where the blind can unroll and is normally inside, you can say, covered. It is inside in this recess. that is not the, that's not the present the situation in India. I think it's, there are not enough people designing building with this. So I think it's but it's not an issue to get today the 3D model of the EMSyS if you take, let's say, known manufacturers.
Right. All right, great. Thank you so much, Pierre and Prashant. These were the questions that we had so far, and we are at about time. This is the time where we usually also, end our webinar. So kind of a perfect timing here. Once again, thank you so much for guiding our students through a rather very important topic. And I hope that our students are able to integrate and, show some really good solutions in their reports using this particular passive technology.
So
Yeah.
just one point, if the student teams are trying to say analyze or doing simulation for EMSyS, and if they need any help, then they can email to us if they feel like. So we are be happy to help them. Great,
that sounds great. All right, so I think the email ID, if you want to contact, would be available on the website. So you can go to GKSPL, the website for GKSPL, and look for the email ID over there. Yeah. And yeah, and with that, once again, thank you so much, Pierre, and thank you, Prashant. Yeah, thank you everyone for joining in. That's all for the webinar today.
Okay, thanks. I think thanks SDI for inviting us.
Yeah.